Yep, thank you. Well, hello. Thank you for coming. My name is Dmitry Pogrebnoy. I'm a team leader of RubyMine team in JetBrains, and today I will talk about Ruby debuggers. We use Ruby debuggers quite a lot in our daily working process, but pretty few of us know how they work internally. In this talk, I will cover open source Ruby debuggers as well as RubyMine Debugger. I've been working on RubyMine Debugger for several years and also investigated how open source Ruby debuggers work. Today, it's a chance for me to share my experience and show you main concept of Ruby.
Just fix our microphone a bit, sorry.
Ruby debuggers, thank you. Let's start. In this talk, I will answer 5 questions. The first one, what tools do we have to find bugs in Ruby code? Then I will show you what technologies do Ruby debuggers use. After that, we will see how do Ruby debuggers work. Then I will show you which debugger is the most performant. And finally, we will see how does the RubyMine debugger simplify debugging process. Let's start from this first question. What tools do we have to find bugs in Ruby code? And let's start from the simple example. Here we have a method process that takes one argument. And in this method, we check whether an argument has toString or inspect methods. If it's true, then we print element is printable. Otherwise, we print element is not printable. And at the bottom, we have 2 calls. The first is process of 5 that prints element is printable. And that is correct because 5 has toString method. But the second call looks pretty suspicious because process of basic object prints element is printable. But in fact, basic object doesn't have toString or inspect methods at all. And apparently, there is a bug somewhere in this code. And I would like to ask you, think for a second, and please raise your hand if you know where the bug is in this code. Don't worry, I won't ask you about that. Yeah, well done. Yeah, so the real problem is here. So this part goes as an argument for defined methods. And in that way, method process prints element is printable regardless of the argument, with any argument possible. We can fix this issue by adding a couple of parentheses for the first part of the if condition. And after that, our output will be correct. So now process of basic object prints element is not printable. This was pretty basic example with almost obvious bug, but what tools could we use to find real bugs in real Ruby code? The first thing that comes in mind is put statement. We can place several put statements to their suspicious place, and they will give us some hints about where the problem is or what we need to do next. And also, in the same way, we can use puts debugger gem that makes our output distinguishable between each other. And also we could use awesome prim gems or similar ones just to make our output more structured and easy to read. Puts really great, but they are pretty basic. We need something more advanced. And we have this tool. We have interactive console. Basically, in Ruby, we have IRB and pry consoles. Usually, we need to place a special call in our source code to make it work. And after that, we will be able to introspect the current context. We will be able to modify it and even evaluate some expressions. But interactive consoles has one problem, the lack of one important feature. And this feature is execution control, basically a stepping feature. And the next tool, debuggers, And Ruby Debugger has all necessary tools to find bugs in Ruby code, and this is the most advanced tool that we have in Ruby world. Before we start with debuggers, let's think how often do Ruby developers use a debugger? And the answer is here. So every third run is a debug run. Basically, 34% of all runs are debug runs. And this fact is based on the anonymous stats from RubyMine version 2024.2. And this fact means that debugging process is the crucial part in our working process. We need to strive to make it even better, to increase our productivity and to get things done with less resources. So that's why I'm here talking about debuggers. Let's move to the next question, and let me show you what technologies do Ruby debuggers use. The first one is a trace point. Trace point was introduced in Ruby 2.0, and it mainly provides an ability to execute some specific code on a certain event in your code. So it's basically provides a way to trace your code. And trace point works almost everywhere. It works in threads, it works in fibers, but it doesn't work in Reactor yet, unfortunately. Hopefully it will be there, but unfortunately not yet. And let me show you an example how trace point works. Here we have a method, say hello, with a puts statement, hello Euruko 2024. And also we have a trace point that is targeted to call events. In this trace point, we have another put statement. And at the bottom, we have a call of our method. And in comments, we have our output. So first, we have a message from our trace point, and only after that, we have a message from our method itself. And in this way, trace point traced our call by placing an additional message. Having only trace point, we can build a probably simplest possible debugger. The main difference from the previous example is here. So in this code, we take an input from the user and we try to evaluate it and print to the console. In that way, we will be able to introspect the context on each call event, so basically on each method invocation. And that's probably simplest possible debugger that we can ever create. And that's why trace point is a crucial part, because without it, it's not possible to make it like that. Let's move to the next technology. It is a Ruby virtual machine instruction sequence. Instruction sequence is a representation of compiled bytecode for a Ruby virtual machine. It depends on the Ruby version because it's tightly related to virtual machine internals. And it mainly provides an access to low-level representation of your Ruby code. With that technology, you can modify the bytecode and adjust the behavior of your program without touching the source code of your program. Let me show you an example. Here we have the same method, say hello, and then we take a method object of this method, and then we pass that method object to instruction sequence. At the end, we just print our instruction sequence to the console in some readable way. So let's take a look at the output. Here it is. Here we have several lines. Each line is a separate instruction. Also, we have our argument, and we can read it right here without any encoding or decoding problems. That's great. And here is another point. These marks show events that will be emitted at the runtime. Here, LI stands for line event, CA for call event, and RE for return event. And in this way, instruction sequence collaborates with the trace point because trace point targets on these events. That's basically it about technologies for Ruby debuggers. And let's move to the next question. How do Ruby debuggers work? First, I would like to start with Byebug debugger. It's pretty well known. It provides all necessary features like breakpoints, stepping, and context introspection. It's default debugger for old Ruby versions and old Rails versions. Also, it requires modification to your source code to make it work. Usually, we need to place a require statement and a call to make it work. And additionally, this debugger provides command line interface by default, and there are several VS Code plugins to make it work. But how does Byebug work? Let's figure out. Here is a simple model of Byebug debugger. All this code should be invoked before the actual Ruby application that we are going to debug. And here on top, we have two lists. The first list of breakpoints that contains breakpoints from the user. And the second list is list of trace point that contains one trace point per each event type. For example, one trace point for line events, one trace point for call events, and so on. In each trace point, we have basically the same method. In each trace point, we try to find our breakpoint at a certain place. If we find it, then we move the control to the user. Otherwise, we just continue our execution without any additional actions. And that's fundamentally how it works. But this approach has one issue, and this issue is performance. The problem is that we do a lot of checks to find our breakpoint on each event, and that makes our code more than 20 times slower than our original run without any debugger. This is the main disadvantage of Byebug debugger, mainly because it could be hard to debug some complicated Ruby or Rails application with that debugger. But next debugger, DebugGem, solved this problem. But before we start with DebugGem, let's see the main feature that solved this problem for DebugGem. And this feature is trace point improvements. Trace point improvements were introduced in Ruby 2.6, and it mainly provides an ability to specify target line or ISEC for a trace point. With that improvement, you don't need to do a lot of checks to find your breakpoint. You can create your trace point and target this trace point to a certain place where you have a breakpoint for sure. And this approach works great without any performance issues. Let me show you an example how this works. Here we have two methods, say hello and say goodbye. Also, we have the same trace point as before without any changes. And the main point is here. Here we target our trace point to the ISEC of the first method. And at the bottom, we can see our output. So our trace point was triggered only once for the first method and was ignored for the second one. That's how it works. DebugGem used that approach to solve performance issue, and in fact, DebugGem doesn't have any performance issue, which is great. Also, this debugger supports Ruby 2.7 and greater, mainly because trace point wasn't ported to the previous versions. Apart of that, this debugger supports several front-ends like VS Code or Chrome. And finally, this debugger bundled in RubyMine version 3.1 and greater. And in fact, this is the default option for debugging your code for the modern Ruby, especially if you don't have any other tools. That's it about DebugGem, and let me show you RubyMine Debugger. RubyMine Debugger is bundled in RubyMine IDE with graphical user interface by default. It provides seamless debugging experience. With this debugger, you don't need to modify your source code. You don't need to deal with some terminal commands. You don't need to configure something. It works out of the box. Apart of that, this debugger supports Ruby 2.3 and greater, so almost all Ruby versions that your application could use. And with all these versions, this debugger doesn't have any performance issues. That's one of the main features. Apart of that, this debugger also has an ability to attach to any Ruby process. So with this debugger, you don't need to start the debugger right from the start. You can attach it when you really need it. But how is the RubyMine Debugger structured? Here is the architecture of RubyMine Debugger. It contains 3 components. The first component is the base gem, and it's mainly responsible for low-level things like ISEC or frames retrieving, trace point creation, and so on. The next component is RubyDebug IDE gem. This component is mainly responsible for text representation of Ruby versions or of Ruby values and for connection between RubyMine IDE and debugger. And finally, RubyMine IDE itself. This component is mainly responsible for graphical user interface and user experience. Generally, architecture looks like this, but the real architecture is a bit more complicated. Instead of one branch of gems, we have 2 branches, and the first branch is targeted to old Ruby. It contains a lot of low-level hacks to make it performant, and it's really hard to support and maintain. That's why we have second branch that is targeted to modern Ruby. It uses new Ruby API. It's much maintainable, and it's easy to add new features here. That's why we have 2 branches, and this approach makes our debugger maintainable and manageable. Another aspect of RubyMine Debugger is the question, how does RubyMine connect to the debugger? Suppose we need to debug multi-process Ruby application. And this Ruby application has 2 processes, the main process and the child process. First, RubyMine starts the main process, and after that, it connects using default port to the main process. Suppose after that, main process creates its child process, and at this point, RubyMine needs to connect to the child process too. To achieve that, child process sends a message with a new connection all the way back to RubyMine, and after that, RubyMine uses this port to connect to the child process. And generally, it works like RubyMine connects to debugger, not the vice versa. This approach works great in almost all cases, but there is one small issue. And the issue is related to Docker container environment. Because in Docker container, we need to open all necessary ports in advance. But unfortunately, we can't predict how many ports arbitrary Ruby application will use, and this is a main problem. We solved that issue by opening large number of ports in advance, just to provide a way for debugging almost any Ruby application with Docker container. But this solution is not very elegant, and probably in future we can make even better. So that's mainly it about how Ruby debuggers work. And let's see which debugger is the most performant. To figure this out, I created a simple experiment. I used Fibonacci method, and in this method, I placed a breakpoint. We never hit this breakpoint, and I need this breakpoint just to measure how a breakpoint can affect a debugger performance. Also, in this experiment, I use average metric of 100 runs, just to make the results stable and reproducible. In this experiment, I used all described versions, and their all describe debuggers and their latest versions. And for RubyMine, we have two packs of gems. The one pack is for modern Ruby and another one for the old Ruby. So let's take a look at the results. Here they are. First, I would like to highlight that Byebug gem really slow with old Ruby. It's more than 20 times slower than original run without any debugger. At the same turn, RubyMine Debugger works fast without any performance issues. And in fact, RubyMine Debugger is the only option to debug your code with old Ruby without any performance issues. That's not really great because we don't have different options to choose, but this is what we have here. For the modern Ruby, we have a better case. We have debug gem and RubyMine Debugger. They are both works on the same level without any performance issues. And for the modern Ruby, we have an option to choose what we can use for each case. That's mainly about debugger performance. And let's move to the last question. How does RubyMine Debugger simplify debugging process? Generally, RubyMine Debugger has a lot of great features that could streamline your debugging process. But I would like to highlight just a couple of them. And the first one is debug Rails application in one click. Suppose we need to debug Rails application. And this Rails application based on the Puma server. Here we can see Puma config file, and here we have 5 threads and 2 workers. It means that our Rails application is multi-process application. And suppose we need to debug it. Let's say we need to debug method home in our controller. And first we need to place a breakpoint by one click on the gutter. And all we need after that is just to click on the debug button, and that's it. We don't need to modify our source code. We don't need to configure something. It works out of the box without any additional actions. After that, debugger process will start and we will be able to hit our breakpoints. And this view we will see when we hit a breakpoint. Here we have a list of frames, special panel with variables and values, and interactive console and other important things for debugging process. That's mainly it about this feature. Another feature is inline debugger values. Suppose we have a method and its filter array. It takes 2 arguments. The first argument is list of numbers. The second argument is just a number. And for some reason, we need to debug this method. So we have a breakpoint on line 4. Suppose we start our debugger and stop on the breakpoint, and this view we will see. Here we have a panel with variables and their values. And usually in debugging process, we need to match variables in our editor with values in this special panel. So we need to go back and forth to make this map in our mind. And it takes a lot of mind resources to keep it in mind and keep it consistent. RubyMine provides simpler solution for this. And RubyMine provides these annotations right in the editor. They show variables and their values right in the editor near the place where you use variable. And this feature can streamline your debugging process and save you mind resources. That's great, I guess. That's it. So let's move to the key points. First, I would like to highlight that Ruby debuggers use trace point and instruction sequence. Also, I would like to emphasize that debug gem works fast due to trace point improvements. And finally, RubyMine Debugger. It works fast with all supported Ruby versions. It enables a one-click debugging process for Rails application and basically for Ruby application too. and it provides inline debugger values to help you debug with pleasure. That's it. Thank you. Lastly, I would like to ask you, take your phones and scan this QR code. Please share your feedback about and RubyMine Debugger with me on LinkedIn. It will be a pleasure to see your feedback, and together we can make our Ruby tools even better. Thank you.